All right, today you're going to do quadratic inequalities. And let's just take a quick look at the title, quadratic, which is ax squared plus bx plus c. Or another word for quadratic is parabola, because that's what the shape the graph makes. And then inequalities. And obviously these are the four types of inequalities we have. Less than or equal to, greater than or equal to. Now, up till now, and in Algebra 1 and in geometry, you've always done equalities. You've always done like the factoring you did the other night, something like x squared minus 9 equals 0. And then you factored it down into x minus 3 and x plus 3. Well, we're not going to have that this time. Tonight's homework is going to look like something like that. We're going to replace this equality with an inequality. Now, before we get into that, let me just point out one other thing. Actually, two other things. Hopefully you know that negative ax squared plus bx plus c gives you an inverse parabola. And if you have a leading positive, it gives you a regular parabola. Sometimes they teach this as a negative means the parabola is sad, and a positive means the parabola is happy. Yay, math. All right, so let's look at a little advancement in math here. I got some random dots that are annoying me, so I want to get rid of them. Goodbye. Up till now, you guys have always graphed equalities. Y equals x squared minus 4. So that means if I pick the point of x being negative 2 and the y being 0, if I put them into the equation, it would equal each other. The 0 would equal, well, negative 2 squared is 4, 4 minus 4 is 0. They would equal each other. And I could pick this, put the 0 in for x, put the negative 4 in for y, and you would get an equality. And that is what the parabola represents. It represents the points where the x values and the y values, if you put them into the equation, you get equal answers. And I'm trying to trace that as best as possible right here. So now we're going to look at the inequalities. So let's pick blue and let's look at a greater than. So if I come over here and I pick this point right here, this is the point 0, 4. So I'm going to put 0 in for the x, and then the y value is 4, so I'm going to put 4 in for the y value, and I get 4 equals negative 4? No, 4 is greater than negative 4. Get it? This is what the problem was asking me. Show me all the points where the y value ends up being greater than the x value squared minus 4. And if you look in the picture, the parabola divides the graph into 3 parts. You can be equal to, which I have here in green. You can be greater than it, and that's any part that's above the parabola. And thus, any points in this blue area will work in the greater than, because all these blue points, no matter which one I pick, if I solve them and put them into the equation, you'll always get the y value being greater than the x squared minus 4. All right, like here, even 0, 0. If I put 0, 0 in here, is the 0y value greater than the 0 squared minus 4? 0 greater than negative 4? Yes. So the blue area shows all my points that are greater than. So obviously, you know what's left here and that's less than. So let's pick red for less than. And where is less than? Less than is everything below the parabola. All these points right here. So if I pick a point in the red area, let's pick this point, 4, 0. So that means if I put a 4 in for x, and I put the y value as 0, that, let me get this out of your way, the 0 value is indeed less than the x value squared minus 4. 0 less than 16 minus 4? Yes, it is. So those are your three areas of a parabola. So really, your homework's even going to be 10 times easier than that. Let's look at this example right here. And I want to pick my pen color to be green so it kind of stands out. This is what your homework is going to ask you tonight. It's asking you, notice there is no y value here. It's asking you what x values make the parabola greater than 0. All right, now I'm going to show you the long way to do it. Since there's an x squared, we factor. So I took my equation, x squared minus 3x minus 4. I set it equal to 0 and I factored it. So I know now that when x is 4 or x is negative 1, my parabola equals 0. Since this is a positive, I know I have a happy parabola. Now, again, you can get this picture by just drawing it on your graphing calculator also. So here's my quick sketch. All right, but this is asking me all the x values that make the parabola greater than 0. So here's a clearer picture of it. And now here's my table. If I put a negative 2 into my equation, is my y value greater than 0? Yes, in fact, I get 6. So negative 2 is an answer. If I put negative 1 in, is my answer greater than 0? No, it equals 0. It's got to be greater than. If I put 0 in, I get negative 4. Is negative 4 greater than 0? Nope. Negative 6, negative 6, negative 4, 0. Nope. Here's the next spot where it's greater than 0. Because if I put this 5 in here, my answer is greater than 0. See, there's my answer all the way up there, 6. If I put a 6 in, I get my answer all the way off the page. If I put a 7 in, my answer is all the way up here. If I put an 8, if I put a 9 in, if I put a 10. So any of these numbers make the parabola go above 0. And in fact, 4.5 makes the parabola go above 0. And 4.1 makes the parabola go above 0. So, does this look familiar? If I drew this number line right here, in fact, any x value greater than 4 makes the parabola go above 0. And over here, this point makes the parabola go above 0, this point makes the parabola go above 0, this point makes the parabola go above 0, this point makes the parabola go above 0. So all these points over here make the parabola go above 0. And those are all the x values that are less than negative 1. So hey, this looks like a disjunction because I have answers going one way or the other. So my answer is exactly that. Come on, go on over there. Any x value greater than 4 or less than -1 makes the parabola go above 0. All right, how about this one? This one is asking, where does the parabola go below 0 or is equal to 0? Because I have a less than or equal to. So I can take out my graphing calculator and I can get this picture. I want to know, where is the parabola below 0? What x values make the parabola go below 0? Let's see, if I put an x value of -3 in, does the parabola go below 0? No, but it does equal 0. So that's an answer. Does -2 make my parabola go below 0? Yep. So does -1. So does 0. So does 1. So does 2. So does 3. So does 4. 5 makes the parabola equal 0. But 6, no. So if I just came over here and graphed all these numbers, let's see, -3 was an answer, -2 was an answer, -1 was an answer, 0, 1, 2, 3, 4, 5. Hey, all these numbers, and remember all the decimals in between them, work. If I put any of these numbers in, my parabola will be below 0. So this is a conjunction because I'm joining the lowest point here, which is -3, and the highest point here, which is 5. So there's my answer. Any x value in between -3 and 5, see, in between -3 and 5, makes the parabola go below 0. And you could have gotten this by factoring. See, there's the 2 points, -3 and 5. Now, it all depends on what you want to do. I like the pictures. The pictures are easy. Hey, if I don't have to factor, I don't want to factor. All right, how about this one? All right, there's my graph. Here's my picture. Once again, this all stands for parabola. And again, we want to go below 0 or equal to 0. Okay, so when I put these x values in, do they give me back answers that are less than or equal to 0? -7 does, -6 does, -5 does, -4 does, -3 doesn't, -2 does, 1 does, -2, -3. Okay, so all those do. Let me come over here and look on this graph. -4 worked, -5 worked, -6 worked, -7 worked. Seems like I'm going this way. They all gave me answers below 0. All right, -2 worked. -1, 0. I don't know why I skipped 0 there. 1 worked, 2 worked, 3 worked, 4 worked. All these numbers this way worked. So, boys and girls, that's a disjunction, because I'm going one way or the other. So now how do we write that? on disjunction form, any x value less than or equal to -4, or any x value greater than or equal to -2. That's what made my parabola go below or equal to 0. And our last problem, it's a double-decker. We're going to look at it both ways. This is asking me, where does my parabola go below 0? It doesn't go below 0. Here's 0 right here. My parabola never goes below 0. So my answer is, oh yeah, that's right, the null set. It don't work. Now, this question is asking me, where does the parabola go above 0? Here's 0, and well, all these numbers. If I put in 0, my answer is above 0. If I put in 1, I'm above 0. If I put in 2, I'm above 0. If I put in 3, I'm all of these. So you're going to learn your first shortcut. Every number in the world works. And that's called all reals. And there's an easy way to write every number in the world. In fact, right now, when you're done with this lesson, if you want to hustle a buck off your little brother or sister, you say to them, hey, give me 10 seconds and I can write every number in the world. And them being little will be okay. And this is how a shortcut to write every number in the world. Make a line, and then right next to the line, write the letter R. That's mathematical shortcut for every number in the world. Okay, now go get your buck off your little brother or sister, and then your parents are going to get mad at you, and then you're going to tell them your math teacher told you to do it. So on second thought, don't do that. Okay, see you tomorrow. Bye.